Now, question of the day. In the following case, a block placed on a horizontal surface like that one experience force as given the each case. Find the frictional force applied by the surface on the block and oscillation of each block. Simply one block here. So you can say that what about oscillation of the block and frictional force? Okay. So first of all, look here. Make free body diagram of 2 kg block. Mg always work on downward direction. For simplicity point of view, I have taken g is equal to 10 meter per second square. Otherwise, you can take 9.8. So 2 into g. So this one is written 2 into g. So 2 into 10, that is how much? 20 Newton. I hope so clear. But look here, that force. Here 10 Newton. That is 10 Newton. Okay. So what about 10 Newton component along x-axis and y-axis? That angle is 37. So if you redraw here, okay, with horizontal 37, this one 37 degree, so that one is also 37. I hope so clear. And this one is 10 Newton. So 10 Newton component along x-axis is how much? 10 cos 37. Cos 37 is 0.8, so that is 8 Newton. And here 10 sin 37, so 10 into 0.6, that is how much? 6 Newton. It means you can say that component of 10 Newton, okay, in x-axis, that is how much? 8 Newton. Sorry, here 8. So direction, that is 8 Newton. And this one is 6 Newton. Here 6 Newton. I hope so clear. Okay. So this one remove and that one remove, and finally make 6 Newton downward and 8 Newton like that one in this direction. After that, if you make free body diagram of that block, mg downward, normal force applied by surface on the 2 kg block is how much? That is, suppose that is n1. This block is not moving along y direction. Why? Because this surface is that is rough surface and also fixed surface. So net force on y direction is 0. So net force on y direction is 0. So you can say that 6 plus 20, 6 plus 20, this is equal to n1. So n1 is how much? 26 Newton. I hope so clear. Why n1 is 26 Newton. After that, determine FL and FK. FL means mu s into n1. Mu s is how much? 3 by 13, and that is 26. Okay. So what about that value? So that is 6 Newton. And what about Fk? Fk is how much? Mu k into n1. Mu k is 2 by 13. n1 is how much? 26. So that is 4 Newton. So finally, how much? 4 Newton. Okay. If this block is moving along this direction, then frictional force develop in this direction. Suppose that is F. Okay. So this block is moving or not decided by driving force and maximum frictional force. Maximum frictional force 6 Newton and driving force is 8. If maximum frictional force is greater than driving force, then block is not moving. But here maximum frictional force, here driving force is 8 Newton and driving frictional force is 6 Newton. This force is greater than this one. Okay, I mean driving force is greater than limiting frictional value. So block is moving. It means oscillation is not 0. If oscillation is not 0, so you can say that net that oscillation is A. So unbalanced force on x direction is written as unbalanced force in x direction is written as, according to Newton's second law, mass into acceleration. So unbalanced force is 8, maximum frictional force is 6 Newton. But during motion, which frictional force are act? Kinetic frictional force are act. Kinetic frictional force is 4 Newton. So 8 minus 4. So written here 8 minus 4, this be equal to mass is 2, acceleration is A. So what about A? 8 minus 4, this 4 divided by 2, that is how much? 2 meter per second square. Okay. So acceleration is 2 meter per second square, and so I have so clear. Now next target is, what about frictional force during motion act? Kinetic frictional force. So kinetic frictional force is how much? That is 4 Newton. So you can say that kinetic frictional force is 4 Newton and acceleration of the block, that is how much? 2 meter per second square if g is taken 10 meter per second square. Okay, I hope so clear. Make it.